Hello, I'm Richard Patterson and welcome to another IPC Irwin video. Today we're going to look at the signal generator, a very common piece of equipment used in science, and we'll just take you through the front panel, the controls and what it does. So coming out of these two sockets on the front is an AC voltage. That's an alternating voltage. So students sometimes have problems with that. It's a voltage that for a certain period of time is going one way around the circuit and then it reverses and goes the other way around the circuit there. Now, connected to it is a voltmeter, which does have a small oscilloscope display on it. And the graph that you see on the screen is showing you how the size of the voltage is changing with time. So we've got volts going on the y-axis, time along the x-axis. And you can see that for this graph, we call it a sine wave, a sinusoidal, the voltage is gradually increasing to a peak, and then it's going down to zero, and then it's going negative, which means the current's running the other way around, and then back to zero, and then that repeats over and over again. Now we can bring in wave theory here as well, because since the x-axis is measuring time, the time for a complete wave, which we call the time period, can be measured from that point there, where it crosses the axis, to this point here. We can measure that time. And as you'll see from this graphic, we have our formula. Frequency is 1 over the time period. If we place the time in there, then we can work out the frequency. Now, this oscilloscope is doing that for us, and it's displaying the frequency there just on the right. And you might be able to read out there that it's saying it's 4.85 kHz. So that's 4.85 kilo thousand hertz. And that's the number of times that this electricity in these wires is changing per second, all controlled by the signal generator. Now, it's these controls on the front that allow you to alter that. So working from the middle, the size of the voltage is controlled by this control here with that black marking on it. So if you observe me turning that down, the display on the oscilloscope is now reduced there. So this is what we call the amplitude of the signal, and we can control that there. Now, the other controls are all to do with frequency, and it's really important that you prep this up. Technicians, teachers work together to understand these controls, because they're basically simple multiplier controls. So on this side, we have the range, the multiplying range. So you can see there's a times 1, 10, 100, and times 1k times 1000. So that's the number you've got to multiply this number by in order to get the frequency in hertz. So we said on the oscilloscope it's around 4.85 or 5 kilohertz. So that should really match what this controls are saying on the front there. Now, if we look at the control, this is on times 100, and I can just, I think, read off there that that's on 50. So 50 times 100 is 5,000 or 5 kilohertz, which roughly matches what we have here on the oscilloscope. So this signal generator is the controls reasonably accurate on the front, and it allows you to control the frequency. Now, this is commonly then linked with studying sound waves, and that brings into electromagnetism that you may or may not have done using loudspeakers and microphones. So if you're happy with the signal generator and what we're doing there with AC electricity, let's connect this simple loudspeaker in parallel with the signal generator. And you can now hear a sound wave being reproduced by the loudspeaker unit here. And the loudspeaker unit is just converting the electricity, the AC electricity, into sound waves. And the pitch or frequency of that sound is 5 kilohertz, which is within our audible range. If you want to test your audible range of hearing, of course, it's a common thing we do in school science, then we just have to turn up the frequency there. And for most human beings, teenage years, the range is from 20 hertz up to 20,000 hertz. Of course, as we get older, our eardrums aren't as flexible and our range diminishes. So it's quite interesting to see at what point, as we raise up the frequency, we can no longer hear the sound. Quite irritating that after a while, so I'll just disconnect the loudspeaker there. So just to recap, the signal generator produces AC electricity. We can control the voltage, the amplitude, and we can select the frequencies. Let's just look at the maximum range this is. If we turn that up to 50, and we turn that up to multiply to times 1K, that means our maximum frequency from this machine is 50K, 50,000 hertz, well above human hearing. Another prop, just to complete the demonstration, is on the right here. Students might want to know what's inside this little thing, and it's the same as we have in our headphones or in our televisions. It's a loudspeaker using the motor effect. It's another topic, electromagnetism, but we've got an example of a very large loudspeaker here that's used for a bass guitar amplifier and speaker, and if we rotate it round, you can see that this card cone, the diaphragm, vibrates up and down the loudspeaker cone, and that's the thing that produces the physical movement of the sound in the air. And we can connect it up to this power supply, and we'll produce a 50 hertz tone there. 50 hertz, very low. And if you're doing this with students, it's quite safe to get them to come and hold onto the cone and just feel it vibrating there, and just to get the idea that something physical is moving up and down as the AC electricity goes through the coil. Inside the rear of the loudspeaker is a coil of wire, and of course you will cover that when you do electromagnetism and you think about how loudspeakers and microphones work. Well, thank you for watching this video. Again, the QR code is here, and we've got all the links there for you to follow this up with set of instructions, safety instructions, and practical teaching notes from the Institute of Physics Spark site.